So in this next section, I want to do a little more complicated example that is going to require us to define our axis of reference for our free body diagram. Here we have a simple cart being pulled up a ramp by force F, and the ramp is from the horizontal, as we can see, an angle theta. So we run into a problem then, kind of as a small problem, of how do we know, if we know all the forces acting on it, which we know that F is pulling up on this and gravity is always accelerating down, how do we illustrate that on our box mg? And how do we relate these two forces in directions? Well, the simple answer is that we need to find a Cartesian coordinate system, which is simply said our xy directions. And what I like to do is I like to take my xy plane and line it up with one of these two forces. You can make it complicated, or you can make it simple, where xy lines up, y lines up with your g, and x lines up with your horizontal. Or you can complicate it a little bit if you really want. Line x up with your force F, and then y is just over here at some offset. But I don't want to do that. That's too much. Let's just take our simple xy plane, and we'll put it here in the middle of our body. So let me get my hand out of your way. Okay? And that's a great place to start. What we'll do now is, as before, I'm going to model this mass M as a point. Okay? And given our handy-dandy new Cartesian system, xy, I'm going to draw that. I'm going to draw xy. I'll use dashed lines for this. Here's my y direction. Here's my positive x direction. I'm only drawing the positive and positive directions because it's implied then this is negative x and this is negative y, because you know that they're all at right angles to each other. What this allows me to do is define my forces now. And I'm going to use purple for all of my forces. I should probably define this in black then, so we don't all get confused. So, I know that G is always acting in the vertical direction, and I've said that Y is the vertical direction. This means that I have force G, well, force mg, acting on my body M, in this negative Y direction. The tricky one now comes from F. But thanks to our new system, our new coordinate system, defining the direction of F is no longer a problem. We do not have to guess. F, as we can see here, is simply drawn up this way. Man, we don't have to be perfect, but this is, you can see the similarities, right, between these two. But what direction is F acting in? Well, if we come over here, we can see that F is acting in the direction of motion of our mass M. And I'll draw it a little bit bigger for you here. Alright, so if this is our plane, here's theta. F is going, and here's our box. F is moving this way. This is just F with nothing else drawn around it. Here's horizontal. So, what direction is F in? Well, this is just this line moved up a little bit. And if I extend my x-axis this way, and I pull this line back here, I'll find that this angle is the same as this angle right here. So then, F is now acting, and can be said to be acting, angle theta from the horizontal, or, as we've defined it, from the x-axis. And now you have this sweet free body diagram with a little bit of extra sauce on it to make your life simple. And that's it. That's the free body diagram for this function, or for this question.